okay? And then we have the combined gas law. So the combined gas law put all the three laws together. And you can see here all the laws. So here is the Lussac, right? So, and here is P1 V1 equal P2 V2. Who is this? Boyle's law, right? And we have V1 T1 V2 T2. We have a Charles law. So all the laws combine together. Again, if you press a little bit of algebra, you're gonna do great because it will make your life easier. Okay? If you, okay, I have P1 V1 T1 equal P2 V2 T2. If you want to isolate like V2, so I need to multiply by T2 both sides and divide by P2 both sides. So this is why I will get this equation over here, and you're going to do this for all the variables that you need to isolate. So since you know the combined gas law, you don't need to memorize all the formulas. You only need to know the combined gas law. If the problem gives you only pressure and volume and saying that temperature is constant, you just take out the temperature and you have the Boyle's law. And if they say, okay, so volume is constant, so you have pressure and volume, so the pressure, temperature, and volume constant, so you use P1, T1, P2, T2. So you need only the combined gas law. You don't need to memorize all those, but you need to understand the concept over here, okay? So let's apply this concept over here. So let's gonna work with this problem. So 10 liters of carbon dioxide gas at 300 Kelvin and 1 atm. So I have volume, 10 liters, and I have, look at here, organized in this table. And you can organize as I'm doing over here. So I have the temperature one, 300 Kelvin, so it's already in Kelvin. And I have a pressure one, which is 1 atm. And if the volume and the Kelvin temperature is double, so that means 20 liters and the temperature is 600 kelvins, what is the final pressure? So you have all the data. Now it's only to apply the formula that you already know. P1 V1 T1 equal P2 V2 T2. You just need to isolate P2 and you have this, okay? So put all your data you have and the pressure will be constant as well, okay? Because you double both volume and also the temperature, okay? So let's do another problem. A gas takes up a volume of 17 liters and has a pressure of 2.3 atm and temperature of 299 kelvins. If I raise the temperature to 350 kelvins and lower the pressure, what is the new volume of the gas? So first thing, my volume 1 is 17 liters. My pressure is 2.3 atm. My temperature 1 is 299 kelvins. And now I have a temperature 2, 250 kelvins, pressure 2 degrees, 1.5 atm, and I want to know the volume. Okay, I have all the data to use. P1 V1 T1 equal P2 V2 T2. I want a volume, so I'm gonna isolate that. So it will be P1 V1 T2 divided by T1 P2. Okay. So now I'm gonna put all my data over here. So I have P1 2.3 liters times V1 17 liters times T2 350 kelvins, and here I have T1 299 kelvins times the pressure to 1.5 atm. So 2.3 atm. So can cut atm, Kelvin, and they can cut Kelvin, and they're gonna have liters. So let's do math over here. So we have a 2.3 times 17 times 350 divided by 299 times, oh, don't forget the parentheses in your calculator, 1.5, and that will give me 30.5 liters. That is my final volume. Okay, so it's not hard. It's more to understand the concepts and how they affect how the variables affect the behavior of the gas, which is not hard to understand. Okay, so here we have a summary. So Boyle's law, study pressure and volume. Charles' law, volume and temperature. So here we know that this is inversely proportional. When the pressure increase, the volume decrease. Oh, I'll put it here. Volume is inversely proportional to pressure. So when the volume increase, the pressure decrease. Charles' law, the volume and temperature is directly proportional. So that means when the temperature increase, the volume will increase. When temperature decrease, the volume will decrease. Here, Lussac studied the pressure and temperature. So here, volume is constant, and all this number of molecules is constant as well. So here, the pressure is constant, and here the temperature is constant. Okay, to study. So here they say the pressure is directly proportional to temperature. That means the pressure increase, the temperature increase, the temperature increase, the pressure increase. Or otherwise, you know that when you increase the temperature, you increase the speed of the molecules, so they will hit the walls more constantly. So just remember, chemistry is all about movement as physics. Okay, and then we have the combined gas law, and I showed you over here that we have the Boyle's law over here, and we have the Charles' law over here. So, and we have the that is the Gay-Lussac law over here, and we have the Charles' law over here. Okay, so we have Gay-Lussac, we have the Charles' law and Boyle's law all combined. So you don't need to memorize all the formulas separately. You know the combined gas law, and you know how to solve it. Just remember how they affect each other. If you know the concepts, you're gonna do great. That's it. That's all. Bye for now.